Okay, welcome to this webinar. So I am Getachew S from Jimma University School of Mechanical Engineering. So the title of the webinar will be the role of open source energy systems modeling, simulation and optimization software tools for developing countries. So outline of the webinar, or we are going to see some few topics within this webinar. The first one is we will see what open source software is, and under that we have some introduction, costs and benefits, general benefits. And then the second topic we will see we will focus now open source software tools related to energy, and under this we will see some categories of these open source software tools related to energy, and we will see very few examples of this under this category. And the second topic will be about benefits of these open source software tools to developing countries. Are they beneficial? We know they are beneficiary for all, but what will be the benefit for the developing countries specifically? And finally we will see that we will have some conclusion and wind up the webinar. So when we come to the introduction, open source software is a software distributed under a license agreement which allows the source code or the computer code to be open. Just so as the name implies, the source code, so this written in bold, so the source code or the computer code is open. That means it will be accessible by the user. So the user can access the source code that makes it to be open, and also the users have the freedom to do with these codes. Okay, they can run the software tools for any purpose. They can study and modify. Also they have the freedom to redistribute copies of these software tools, either original or modified. Okay, so the user can distribute original software tools or can modify it and then distribute it. So so opposite to the open source softwares is proprietary software or the closed software, where the user cannot have access to the source code. Okay, so it's impossible to make any modifications to these proprietary softwares as opposed to the open source softwares. And open source software can be commercialized. That means in one way or another we can commercialize these open source software tools. That means it's free, the source code is free, but other services related to these open source software tools can be commercialized. So the user has the freedom to use it also for commercial purpose. So when we come to the second topic about the cost. So open source software is free. That means the source code is free. But there are other things related to these open source software tools which require, or which makes it sometimes makes it commercial. For example, the open source software requires certain level of technical expertise in order to manage the content. So now the cost comes in this area. So open source software providers are increasingly charging for add-ons, additional services and integration. Yeah. So even though the source code is free, it's because of the add-ons or the additional services or integration. For example, one can to create a graphical user interface, how to display the outputs of the codes, computer codes, and so because of that, that person can ask for some payment. Or you can also conduct trainings, okay, to train open source software packages. Again, you can ask for payments and so on. So this makes it a bit commercial. Even though the source code is free, some additional things done with these open source softwares may not be free. So and the user still has the freedom. Okay, even though he gets the source code for free, he can play with it and make it non-commercial. So in general, the total cost of ownership for open source software may roughly equal some closed source options. Okay, so the user should be very careful. Yeah, so we say that the source code is free, but because of the additional costs related to training or maintenance or additional services and integration, the costs sometimes can be high, and so the users should be very careful when deciding to use open source software tools. Now we will see some general benefits of the open source softwares. One is the cost minimization. Okay, if we can handle the management costs and other additional add-on costs, then the source code is free, so because of that we can minimize the cost. And the other advantage is it maximizes the control of our control or our computers. Okay, so as we use open source software tools, we can have more access to control our computers or our software, because we have an access and we can modify, we can change, or we can improve, or we can remove unnecessary parts and so on. So we have the control over our computers compared to using the proprietary software tools. The other one advantage is we can also contribute to the cultural heritage. That means we can, since we have access to the source code, we can change these codes, even we can translate them to our own language of different countries. So because of that, we can inherit some cultural issues into the software. And the other one is freely available and guarantees legal security. As the beginning, we say that there is a license agreement for these open source software tools, and because of this license agreements, we are free of any legal issues. Okay, so it guarantees legal security. And actually, because it is universal access for studying the software tools, so we have access, so we can study on it, especially in educational areas. So it will be very helpful to teach students in this area. So that's some of the general advantages of using open source softwares are this. Now that was general thing about open source software. We will see only now, we will focus only on those related to energy. Yeah, this webinar is being sponsored or conducted under the framework of the Energise project, which works on the energy area. So because of that, we now focus on energy, even though also energy is a global issue these days. So we start with the definition of energy, the simple but very important definition of energy, which says energy is the capacity to do work. So because of this reason, now we focus our interest in this area. So the open source software tools related to energy can be somehow categorized under these few categories. For example, most of them are under the system planning, energy system planning. Some software tools go under the category of energy efficiency tools, and others go under the financing tools and infrastructure, and finally power system design and project planning. So these are the main categories, but still we are going to have a number of categories. And when we talk about energy related softwares or modeling softwares, okay, we can have, for example, the energy system planning. So for that, we may consider this power plant as an example. Okay, this is a solar thermal power plant. Okay, so from here we have solar energy as an input, and we have parabolic trough collectors here, and so here we have some closed cycle, and this solar field cycle is attached to a power block here, which produces the power at the end by making use of the generator attached. So now one example is of the open source software is just to model this process. What is the input, solar radiation data we have, the geographic location data we have, and so on. We can simulate, model the whole process, and finally simulate and calculate the output, the electrical energy output at the generator. Okay, so before trying to implement such huge power plants, we can use these software tools to model and simulate the output. For example, we may size the number of collectors we need here, the size of the tubes or the heat exchangers we use here, turbine, and all components can be sized before actually implementing this huge power plant. So it helps us to save our money, our energy, time, and etc. So these softwares are very helpful in energy systems modeling and simulation. So this is why we study, or why we have to focus on trying to find out softwares which are available to make this modeling and simulation for us. But unfortunately, most of the softwares we have are they are expensive, they are commercial, or they are proprietary. We cannot have access to their codes, and also they are commercial. So because of that, now, even though we have a problem in every country regarding to energy access, okay, but the modeling software, the simulation software we use are very expensive, and that hinders us from having our own energy-related power plants. So this makes us to shift our attention from the proprietary ones to the open source software types. Okay, when we come to the some examples, there are a number of free and open software tools developed for the purpose of modeling and simulating energy systems. So we will see just few of only these software tools. The first one is what we call the Osmosis. Okay, so this is an open source energy modeling system. Okay, it's a full-fledged system used for optimizing for long-term energy planning. Okay, so it is more interested, or the developers of this software are more interested in the planning and optimization of the full-fledged system for a long run, and it requires also a less significant learning curve. That means it doesn't need more involvement in the source code, yeah, and also it does not use any proprietary software or commercial programming language and solvers. So everything is very free and open source. The other example we have is what we call the OGEMA, or Open Gateway Energy Management. Okay, again, this is an open software platform that supports standardized building automation. So this is more related to building automation and energy management. So the energy management issue is very important issue, just equivalent to having or developing new power plants. It's also very important to manage the energy that we already have, or the energy supply we already have. And so there are a number of software tools developed to help us in managing the our energy utilization. Okay, so this software OGEMA can be applied at household level, or it can be applied for commercial environments and even industries. It also this software links the customer's load and generators to building automation and energy management applications. The other one is OpenEnergyMonitor. And again, this is a project, it's not software. Actually, it's a project which develops a software or a software tool, an open source software tool. This is very important software because it includes some physical or hardware. It's not only a software, but it also includes some software, especially sensors. Okay, so and the other thing is that it is the sensors are, the number of sensors are there, and these sensors, they record data, and those sensors are wirelessly connected to some web connected station. So that means there are sensors that we use, so the data sensed by those sensors is directly sent to our software, which is web based. So we need a wireless connection between the sensors and the software. So there is no physical measurement done by the user. So it's just recording of the data and directly loading it into our software. So after collecting all those data, it will do all the management or the analysis activities for us. So this is very interesting software. It can be used for home energy, it can be used for solar PV, and for remote temperature monitoring issues. And the other one we have is Energise S. Again, this is an open source application for monitoring, storing and analyzing energy related data, for optimizing energy use and detecting energy leaks or energy wastage. So the important feature of this software is that it is used for storing purpose also, large size data. Normally when we deal with energy management issues, we are going to collect large size data, and this large size data should be stored somewhere and also should be processed. Okay, this large size data should also be processed. Okay, for storing and for processing this large size data, the special feature of this software is that it uses parallel processing. That means more than one computer processors are involved in the data storing and processing. So this makes it very special and very comfortable for dealing with large size data which are mainly obtained from energy resources. And the other one we have is what we call the Calliope. Again, this is an open source energy systems modeling framework. Again, this is related with modeling the complete energy systems. Okay, so in addition to dealing with the spatial cases, it also handles the temporal issues or temporal resolutions related with time. Okay, so it can handle some transient changes to the data input we have and so on. So this transient nature also is a feature of this Calliope software. And the other software we have is QBlade, which is very much related to the wind energy or wind turbine design. Okay, so this is very specific to wind turbine or wind energy. The former ones we have seen are more or less general, but this one QBlade is more specific, and it is used only for the purpose of simulating or designing a wind turbine and performing aerodynamic simulation. Okay, so it comes with a very user-friendly graphical user interface, which is based on Qt. Okay, so this makes it very special. And the other one we have still related to wind turbine is what we call the Vortex J. Again, it is an open source and it's more of computational fluid dynamics. Okay, so it solves the continuous governing equations of aerofoils, especially it's based on what we call the source doublet panel method. And the other advantage of this is that it can be connected with C++ API, so and other simulation softwares, so you can use it to work with other simulation environments and also it's easy to post-process the results of the simulation. The CFD simulation can be easily post-processed with other post-processing softwares like ParaView. And coming to the solar ones, we have another important open source software, what we call PV Mapper. Okay, so this is something related with PV or solar photovoltaics power plants. So again, this is a web-based, and it also incorporates some GIS or graphical information system. So by making use of this geographical information system, we can record the data where our PV system is implemented, and it also helps us to compare the site. Okay, so the site comparison capability. If we implement our PV system in Africa or in Europe or somewhere else, okay, we can make some comparisons, or even in the same location we can have different areas where we can make site comparisons, or the effect of the site, the geographic location, and so on the power produced by this PV power plant. The other one is the Energise. The Energise is another very important and a bit older open source software. It's actually a commercial, but the open source code is open again, so the users can access to the source code and can make some modifications to it, or even they can use it for other purposes. And this Energise software is more or less a general purpose. Okay, so it can be applied for all thermal and renewable generation, except maybe nuclear, wave, tidal, and hydropower. For the others, it can be used. So we have seen few of the freely available open source software packages, but still we have a number of them which are not mentioned in this webinar. So interested users can go to this website and can see which one is of their interest. Finally, when we come to the benefits of this open source energy systems simulation and modeling and optimization softwares, we see some of the benefits. One is to compete in the knowledge economy. That means because of our access to the source code, okay, so we can use these softwares freely, and we can construct our own power plants, solar or biogas or any other energy related power plants, and that will have an effect on our economy, especially for the developing countries. And the source code can be used for local purposes, so it has something with the cultural heritage, and we can use for development of simple systems, and locally based software industries can be started because of the open source or the access we have to the source codes. Local industries can be started. Maybe entrepreneurs can do some kind of training or upgrading and etc. to the softwares they access, and that can help them to generate their own money for living. And the other one is, as already said, we have a control over our computers, and this will make us to have a control on the overall energy modeling, simulation and optimization process in general. And collectively all those advantages can have an effect on the overall effect of positive impact on the nation's economic development. So to conclude, we already said that energy is a capacity to do work, and any type of development, be it for a developed country or a developing country, any kind of development work is unthinkable without energy. And the energy producing power plants or energy systems, they need to be modeled, simulated and optimized before actual implementation. and to do this modeling, simulation and optimization, and because of cost effects and other or benefits mentioned above, okay, the open source software packages are good options compared to the proprietary ones if they are selected in a very careful way. So thank you very much. I will stop the webinar at this point.